Determine the change in volume of 6 liters alcohol if the pressure is decreased from 200 centimeters of Hg to 75 centimeters of Hg. Velocity of sound in alcohol is 1280 meters per second. Density of alcohol is 0.81 gram per cc. Density of Hg is 13.6 gram per cc, and G can be taken as 981 centimeters per second square. Now, if you look at the options, options are given in terms of milliliters. What does that mean? That simply means we have to use all the other parameters in terms of CGS units. All right? Okay. So now let's note down what has been given in the problem. The rise of height 75 centimeters of Hg, H2. H1 is 200 centimeters of Hg. Density of mercury is 13.6 gram per cc. And for alcohol, it is 0.81 gram per cc. Speed in alcohol is given as 1280 meters per second. Initial volume of alcohol is 6 liters. What else? G. G is 981 centimeters per second square. Now we have to find the change in volume. How should we proceed? Tell me, what can you think of? On your screen, you can see one formula. B is equal to V square rho. That we have studied in the chapter of sound waves. B is equal to V square rho. Now this is the formula, this is the equation for bulk modulus from the chapter sound waves. What about its original formula, which we studied in fluids? What is the formula? B is equal to minus del P divided by del V by V. Right? Yes. Why am I writing this formula? What is the need? Because we have to find the change in volume. If you look at what has been given in the problem, you will surely figure out that why we need this formula. Because in this formula, we have change in pressure that we can figure out from the question. Del V, we have to find. Initial volume, we have been given. From this formula, if we look at the first formula, V is the speed that is given, 1280 meters per second. Density is given, right? So all the parameters other than del V, we have, right? So now let's proceed. But before proceeding with this formula, before using this formula, let me write this formula on the side. B is equal to minus del P by del V by V. All right. First of all, look at the pressure. Pressure has been given in terms of rise of height, in terms of centimeters of Hg. And if we have to know the pressure in terms of SI unit or CGS unit, we have to use this formula. P is equal to rho GH, where H is the rise in liquid. Yes, can you remember this from the chapter fluids? I am not going in detail for this formula because I know you know this. Okay? All right. So first of all, let's say P1. P1 is rho GH1. Let me write it in capitals. Rho GH1. P2 is rho GH2. Okay, fine till now. All right. Now moving further. Bulk modulus, two formulas. Can we equate them? Yes. V square rho is equal to V. Let me write in short because we have two V's. One is velocity and the other one is volume. So just try to differentiate. Okay. V square rho is equal to minus del P divided by del V by V. Okay. Now moving further. V square is speed. Since we have to find the change in volume in milliliters, we have to use all the parameters in terms of CGS unit. The speed is given in meters per second, 1280 meters per second. So if we write it in centimeters, it will be 1280 into 10 square centimeters per second whole square. Density. This will be the density of alcohol because the sound is traveling in alcohol. And density of alcohol is given as 0.81 gram per cc. That is already in CGS unit. No need to convert. Is equal to minus del P. Del P is the change in volume, which is P2 minus P1. Del P will be P2 minus P1. And that is why in place of P2, I am writing rho GH2 minus rho GH1. rho g h1 divided by del V we have to find. So del V divided by V, the initial volume. Initial volume is 6 liters. And in milliliters, it will be 6,000 milliliters. Fine till now. Look at the screen once more from top to bottom. From where we started and right now where we are. Can you see? Can you figure out what we have done? Yes? Okay. So moving further, let me write it on next slide. 1280 into 10 square whole square into 0.81 is equal to, let me see once more, minus rho g h2 minus rho g h2 minus rho g h1 divided by change in volume divided by initial volume. Okay. All right. Now if we move further, 128010 square whole square into 0.81 is equal to, this is minus of rho g h2 minus rho g h1. So this will be rho g h1 minus rho g h2. So rho g h1 minus h2. Can I write it like this? Yes? All right. So now let me place the values here itself. Rho, density of mercury, 13.6 multiplied by G. G is 981 centimeters per second square. That is why, because we have to find the volume, the change in volume in terms of CGS unit. That is why G is also given in terms of CGS unit. Okay. So 981 into H1 minus H2. H1 is 200 centimeters minus 75 centimeters divided by change in volume del V by 6,000. Pretty long equation, but if you know the concept, calculations are always easy. All right. Okay. So in this equation, you can see that other than del V, we have put in all the values. We have plugged in all the values. And after calculations, you will get del V as 0.75 milliliters, approximately equal to 0.75 milliliters. Okay. So the calculation was tough. The calculation was long. It was complicated, but the concept was easy, right? Okay. If we look at the options, which option is correct? Option B is the right answer for this question. A tuning fork with a time period of 1 by 256 seconds produces a sound wave which has a separation between adjacent compression and rarefaction of 0.7 meters. Then the speed of sound is 250 meters per second, 400 meters per second, 310 meters per second, or 358 meters per second. So the question is basically trying to say there is a tuning fork, it is vibrating, and the vibrations have a time period of 1 by 256 seconds. Now what else? The separation between adjacent compression and rarefaction is 0.7 meters. We have to understand this statement first. The separation between adjacent compression and rarefaction. First of all, one question. How do we define the wavelength of a wave? Tell me, in terms of compressions and rarefactions. Let's say we have one compression C1, then we have a rarefaction R1, then C2 is another compression, R2 is another rarefaction. Wavelength is the length. Wavelength is the distance between two adjacent compressions. Wavelength is the distance between two adjacent compressions or two adjacent rarefactions. I'll repeat this statement once more. Wavelength is the distance between two adjacent compressions and two adjacent rarefactions. Now, if you look at the diagram, the length C1, C2 is equal to lambda. The length R1, R2 is equal to lambda. The question is saying the distance between adjacent compression and rarefaction is 0.7 meters. Distance between adjacent compression and rarefaction. That means C1, R1. If we are saying C1, C2 is lambda, what should be the length of C1, R1? It will be lambda by 2, right? The distance between adjacent compression and rarefaction will be lambda by 2, and that is what the question is mentioning. lambda by 2 is equal to 0.7 meters. Understood the funda till now? Yes or no? Yes. Nothing difficult, right? We can figure out if we know the definition of lambda, then we can easily figure out what the question is trying to say. Okay? So lambda by 2 is 0.7 meters. That is why lambda will be 1.4 meters. Now let's erase all of this. What we have to find? We have to find the speed of sound. Speed of sound. What we have been given? Lambda is 1.4 meters. Lambda is 1.4 meters. Time period is 1 by 256 seconds. You have the formula as well on your screen. The formula is speed is equal to wavelength by time period, or speed is equal to lambda, wavelength into frequency of sound. Correct? Okay. So V is equal to lambda by T. Lambda is given as 1.4 meters. T is given as 1 by 256 seconds. Okay. After calculations, you will get 358 meters per second, and that is what we have to find out. The speed of sound is 358 meters per second. Easy? Of course, easy. Okay, so which option is correct? Option D is the correct answer for this question. Speed of sound in air at constant temperature is proportional to atmospheric pressure, is proportional to square of atmospheric pressure, is proportional to the square root of atmospheric pressure, or does not depend on atmospheric pressure. Now, after reading this question, you will straight away go to this formula. V is equal to root over of gamma P by rho. And from here, we can say V is proportional to root over of P. That is why the speed is proportional to square root of pressure. So which option should be correct? Option C should be correct, right? Wrong. Read out the statement once more. It is saying atmospheric pressure. Atmospheric pressure. This pressure is not atmospheric pressure. It is the pressure, it is the value of pressure at that point where we are calculating the speed of sound. The pressure in that medium at that point, right? This is that pressure, not the atmospheric pressure. So how can we say that it depends on atmospheric pressure? No, it does not depend on atmospheric pressure. That is why option D will be correct. But we can say one thing, that the question is saying that constant temperature, speed of the sound at constant temperature. So we can say that, yeah, from this formula, V is equal to gamma RT by M. For a particular medium, temperature is constant, so velocity will be constant. That I agree. But the option is talking about atmospheric pressure, and straight away we can say that it does not depend. The speed of sound does not depend on atmospheric pressure. Okay, got it? All right. So which option should be correct? It does not depend on atmospheric pressure, and that is why option D is the correct answer for this question. Which of the following graphs represent the correct variation of velocity of sound with the pressure in a gas at constant temperature? Constant temperature, mark these words. We will use it while we are analyzing, while we are using our equations. Okay. So which of the following graphs represent the correct variation of velocity of sound with the pressure in a gas at constant temperature? And here we have our options. Closely look at the options and try to analyze which one can be correct. First of all, how we have to proceed? Speed of sound. Speed of sound in a medium is given by gamma RT by M. We have four parameters, gamma, R, T, M. For a particular gas, gamma will be constant throughout the medium, right? Mass, molar mass will be constant because we are using a particular gas throughout the medium, correct? R is already a constant, and the question is saying that temperature is constant. All of these parameters are constant. So if gamma is constant, R is constant, T is constant, M is constant, then speed is constant, right? So from this equation, we can say that if temperature is constant, velocity will be constant, speed will be constant, right? But we have one more equation that can create confusion. What is that equation? The equation is V is equal to root over of gamma P by rho. So we can say, sir, pressure is changing. If pressure is changing, speed can change. We just know about the temperature. We don't know about the pressure, whether it is changing or not changing. But my dear friend, if pressure is increasing, just imagine, if at a point in the medium pressure is increasing, density will also increase, right? If pressure will increase, density will increase. That means numerator and denominator both are increasing. If pressure will decrease, density at that point will decrease. So if numerator is decreasing, denominator is also decreasing. If numerator is increasing, denominator is decreasing. That means from this equation also we can say that speed will be constant. Got it? Okay. So this was the analysis. This is the only analysis we can do. And from here we can say that V will be constant. Speed will be constant. Now coming to our question and the options. In the option A, velocity is varying. Option B, velocity is varying. Option C, velocity is changing linearly. In option D, velocity is constant. We have a straight line graph. And that is why option D is the right answer for this question. Speed of sound in air is 332 meters per second at NTP. Now, what will be the speed of sound in hydrogen at NTP if the density of hydrogen at NTP is 1 by 16 that of air? Options are 664, 1328, 1155, or 166 meters per second. Now, if you read out the question once more, you can see that the question is mentioning NTP 3 times. What is that? What does that mean? NTP is normal temperature and pressure. Now, in question, we have 2 cases. What are they? First, the sound is traveling through air. Second, the sound is traveling through hydrogen. Right? And these both cases are happening at same temperature and pressure. At same temperature and pressure. So, for both the situations, temperature and pressure are constant. They are same. Okay? Now, moving to our calculations. First of all, velocity or the magnitude of velocity in air is 332 meters per second, and given that rho h by rho air is equal to 1 by 16, the formula is V is equal to root over of gamma P by rho. Now, from here we can say that speed is proportional to 1 by rho. But there is a confusion here. What is the confusion? You can say that, sir, in question it is saying that pressure is constant. Okay, agree. Pressure is constant for both the situations. What about gamma? How you are taking gamma as constant? So, my dear friend, we assume that in air we have nitrogen, oxygen, and hydrogen. Mostly, the air is occupied by nitrogen and oxygen, right? Hydrogen is in a very trace amount, very little amount. But mostly, the air is occupied by nitrogen and oxygen. Now, gamma for monoatomic is 5 by 3. For diatomic is 7 by 5. For triatomic is 9 by 7. Right? In air, you can see that if we consider that all the air has been occupied by nitrogen and oxygen, we will say that gamma is 7 by 5. Right? Now, coming to hydrogen gas, hydrogen is a diatomic gas. That is why gamma will be 7 by 5 for hydrogen as well. So, what you can conclude? Gamma is constant for both the situations given in the problem. Correct? Okay. So, here we have figured out that gamma is also constant. In question, it is saying that pressure is constant. Okay. Now, moving further. V is proportional to 1 by rho. So, we can say that VH by V air is equal to root over of rho air by rho h. Got it? Any problem? No? Okay. So let's place the values. VH by V air is equal to root over of rho air by rho h, Rho h by rho air is 1 by 16. So here we can place 16. Or let's say in place of root over of 16, let's directly write 4. 4 square is 16. Right? Now, if this denominator goes on the other side, this will be VH. VH is equal to 4 times V air. And V air is given as 332 meters per second. So 4 into 332 will give our answer. Right? Look at it once more from where we started and now where we are. I think you must have solved this problem. This is not a very difficult problem, right? Okay, so let's quickly write the answer. What is the answer? The answer is 1328 meters per second, and that is why which option is correct? Option B is the correct answer for this question.